This is the last chapter of your syllabus. It's chapter number 18, tangent and secant properties. This is the chapter on circles. First chapter was about chord properties, now about tangent and secant properties. Now, we have seen 5 properties already in the previous chapter about circles. The 6th one is the tangent at any point of a circle and the radius through the point are perpendicular to each other. Look at this figure. There is a circle and the center of the circle is O. Now this line that you can see, PQ, is a tangent. PQ is a tangent. A tangent is a straight line which comes from infinity. It touches the circle at one point and goes to infinity. Okay. So this tangent PQ touches the circle at A. So this point A is called the point of contact. This point A, which touches the circle and the tangent, that point is called point of contact, and A is the point of contact. Okay. The property is the tangent at any point. This is the tangent at any point means the point is at A. Okay. At any point of a circle and the radius through the point, this line that you are seeing, OA, is the radius of the circle. It doesn't say radius drawn anywhere. It says radius that is drawn to the point of contact. PQ was the tangent, A was the point of contact. The radius that is drawn is from the center of the circle to the point of contact, not anywhere else. Okay. So this tangent and this radius, which is drawn to the point of contact, are perpendicular to each other. That is, the angle made here is 90. This side is 90, this side also is 90. So tangent and radius are perpendicular to each other. The radius is drawn to the point of contact. So these two lines will be perpendicular. That's theorem number 6. Next is theorem number 7, or property number 7. If two tangents are drawn from an external point to a circle, then the tangents are equal in length. If you look at this figure, this is the circle with center O. If two tangents are drawn from an external point, this is the center of the circle. I assume a point which is outside the circle. Outside the circle, that is point X. This is point X. Which is outside the circle, that's point, the external point. X is the external point. If two tangents are drawn from an external point, you will see that from X you can draw only two tangents, not more than that. Okay. One is X to P, touching the circle at P, and the other one is X to Q. You can draw this, extend it more. Okay. So it's the same tangent. So XP is one tangent and XQ is the other tangent. So there are only two tangents that you can draw from a point which is outside, an external point. So if two tangents are drawn from an external point, these are the two tangents which are drawn from an external point to a circle, then the tangents are equal in length. These tangents that you are seeing are of equal length. That is X to P, this length, XP. XP and XQ will be equal. XP is equal to X. These two lengths will be same. Okay. So that's the next property. Using these two properties, we are going to do an exercise. Exercise 18A, question number 1. PB and PC are two tangents to a circle meeting it at B and C. There is a circle. PB and PC are two tangents which come to the circle, touching the circle at B and C. If PB is 5 cm, P to B, this length is 5 cm. Find PC. Okay. We are going to use the second property which I said. P is an external point. From an external point, you can draw two tangents to a circle. The first tangent is PB, the other one is PC. Okay. So So two tangents are drawn to the circle from an external point P, and both these tangents must be of equal length, which means PB must be equal to PC. If this is 5, this also must be 5. So statement for that. PC is equal to PB. PC is what you need to find, is equal to PB. Both are equal because they are tangents from an external point. Okay. Tangents from an external point are equal. So both of them are equal. So PC is equal to PB's length was already given. PB was 5 centimeters, so PB is 5 centimeters. That's it. PC's length is 5 centimeters. Next question. Question number 14. In the adjoining figure, ABC is a right angle triangle. This is the figure given. ABC, this one is a right angle triangle, right angled at B. This is 90. With AB is 6, A to B is 6 centimeter. This length is 6 centimeter. Okay. This much is 6 centimeter. And BC is 8. This length, BC, is 8 centimeter. A circle with center O, this one is the circle with center O, has been inscribed inside the triangle. It is inside the triangle, touching all the three sides of this triangle. Okay. So that's an inscribed circle. Calculate the value of x, the radius of the inscribed circle. X is the radius of the inscribed circle. This is the inscribed circle. You can see this is the center. This length is the radius, which is x. This length is also radius, which is x. This length is the radius, which is also x. Okay. You have to find the value of x. Okay. For that, look at this figure again. Now, this angle you can see is 90. Why this was 90 is this is the radius, this is the tangent. The first one which I said was tangent and radius which is drawn to the point of contact are perpendicular. It was already given in the question. This is 90. Okay. So if this is 90, the angle below also must be 90 because sum of angles is 180 here. Okay. So both of them are 90. This one is 90, which was already given. Triangle ABC is a right angle triangle, so this is 90. Okay. This one is 90, which was marked in the figure. Or this is the radius drawn to the point of contact. This is the tangent. They should be perpendicular. Okay. So this is also 90. Now if you look at this figure, ROPB, this one, ROPB, you will see three vertex angles. Okay. These three vertex angles are 90, which means the fourth vertex angle also must be 90 because this plus this plus this plus this should give you 360 degrees. This and this 90, 90, 90 will give you 270. So the fourth angle should be 90. So this is also 90. Okay. So if all the four angles are 90, then this figure ROPB must be a rectangle or it must be a square. Now let's see whether it's a rectangle. If it is a rectangle, you have length and breadth. This board is a rectangle. It has a length and breadth which are different. Length is a little longer than the breadth. Okay. But look at this. If this was the length and if this was the breadth, then they should be different if it is a rectangle. But look at the marking. This is x. This is also x. Both are equal. So in a rectangle, you cannot have both these adjacent sides equal. Okay. So this cannot be a rectangle. It has to be a square. So if it is a square, this is x. This is x. All sides must be equal. X, x. This is x. Okay. So this much is x. And this side is also x. That much is also x. All four sides are equal. So that's what I've written here. Since OR is equal to OP, OR is equal to OP, both were given to be x. And the four vertex angles are 90. All four vertex angles are 90. ROPB, this figure, ROPB is a square. So RO, this one, must be equal to PO, must be equal to BP, must be equal to BR. All must be equal to x centimeter. So all of them are marked x. Okay. Next. Now if you see, I'm going to find, see this whole length is 6, this much is x. I'm going to find A to P, that length, or P to A. PA is BA the whole thing minus BP. BA minus BP. PA, this length must be equal to whole length BA minus BP. So PA is equal to BA, B to A whole thing is 6 minus BP, this much is x. So PA, this one is 6 minus x. This much is 6 minus x. Okay. That's the first one. And for the next one, CR is equal to CB minus BR. I'll show it in the figure. CR, this one, I'm going to find this one. CR is equal to CB minus BR. This length is equal to whole length minus BR. Okay. So this length CR is equal to, so that's what I've written here. CR is equal to CB minus BR. So CR is equal to CB, the whole length of this side was 8 minus BR's length, that small one, was x. So CR's length is 8 minus x. Let's mark that. CR's length, this one, is 8 minus x. This much is 8 minus x. Now, let's go to this. This is the circle. This is an external point. From this external point, there are two tangents which are drawn. AP is one tangent, AQ is the other tangent. So if there is a circle and if there is an external point, you can draw two tangents. These two tangents must be equal. So if this is 6 minus x, this is also 6 minus x. Okay. So this much is also 6 minus x. Similarly, this is the circle. This is an external point. From this external point, there are two tangents which are drawn, CR and CQ. Both must be equal. Okay. This is 8 minus x, which means this is also 8 minus x. So this is 8 minus x. Okay. The question was to find the value of x. But in the beginning it was given this figure is a right angle triangle. No, before that, before I explain that, I have to write statements for these also. I marked this is 6 minus x, this is 8 minus x. Okay. So statements for that is QA is equal to PA, because tangents from an external point, the lower one which I showed you. So QA is equal to PA's value was 6 minus x, PA is 6 minus x. So QA is also 6 minus x, which I mark on the hypotenuse, 6 minus x. Similarly, QC is equal to CR. They are also tangents from an external point, the upper one which I showed. Okay. So QC is equal to CR is 8 minus x. Okay. So this also I marked on the hypotenuse, 8 minus x. Now, in triangle ABC, in this whole triangle, you know this side is 6, you know this side is 8, you know base, you know perpendicular, you can use Pythagoras' theorem and find the hypotenuse. So that's our next calculation. So our next calculation is in triangle ABC, CA square, that's the hypotenuse square, is equal to CB square plus BA square, perpendicular square plus base square. That's Pythagoras' theorem. So CA square is equal to CB square, perpendicular was 8 square, plus base was 6 square. So CA square is equal to 8 square is 64, plus 6 square is 36. So CA squared is 100, if you add this. So CA is equal to square root of 100, which is 10. So hypotenuse length is 10 centimeter. Okay. Now look at the figure. This hypotenuse length you got is 10 centimeter. But look at the hypotenuse, it's made of two parts, this and this. This is 8 minus x, this is 6 minus x. If you add this and this, you should get 10. Okay. So our next calculation is that. So CA was the hypotenuse. It is made of two parts, QC and QA. If you add both of them, you will get this is equal to 10. QC is 8 minus x plus QA is 6 minus x is equal to 10. Minus x is minus 2x, goes that side. 10 comes this side. 8 plus 6 is 14 minus 10 is 4 is equal to 2x. So x is equal to 2. X was actually the radius of the inscribed circle. Therefore, the radius is 2 centimeter. Your homework for today is exercise 18A, question numbers 3, 15, 16, 17 and 18.